Hey, I'm Trent, and you're watching My Geek Show. On this episode, I want to introduce you to the newest version of the Raptor 140, the Raptor 140C. Now, by no means is the Raptor 140B over. In fact, we're going to keep flying it here almost every single day. But really, we have to get to the next level. We have to get closer to the USA trip. And the Raptor 140B technically could do it. We just need more flight time and more avionics to be able to communicate between us on the RC airplane. Let me show you what we got. Okay, here it is, the Raptor 140C. It is based, of course, on the Raptor 140 platform. It is literally the same Raptor 140 wings and everything as I sell on my store. Nothing modified in any way. So that's the Raptor 140. That means it's going to have a 140 centimeter wingspan, or about 4.6 feet. The CG is going to be back 26 centimeters right here, where you can see that kind of main wing spar here. And 26 centimeters from the nose means the CG is just about as balanced as you can get. It's going to have almost zero reflex or sweep. So these elevons are almost going to be completely neutral, which is good for efficiency, but it does make it a little tip stall prone. So just something to be aware of as you pilot this kind of airplane. You'll need to be careful or cautious when you're going slower. At any rate, the material is going to be EPP foam, so no change there. I should say anything in black, any text in black is no change. Red is modified. So let's keep going, just a kind of a key there. The motor support, basically, I have extra layers of laminate to support the motor mount area. Now the leading edge, I'm going to add a layer or two of 5mm laminate. As this airplane is going to be landing faster and in probably more different locations, like I did on the cross-country trip, it's not going to land at the same field. I may not always be able to choose the most ideal landing setting. It might be, land in some brush, and so I need a little stronger than that just a single layer of 5mm laminate can provide. Now the wing spars, the prior version had 4.5 meters of total wing spar of carbon fiber wing spars. This is going to go up to 6.4 meters, or 21 feet of total wing spars. It's a lot of wing spars, but it's just additional support and strength as it's going to be a little heavier. The elevons are the same size, 5 centimeters by 48.5 centimeters. Gives it plenty of control authority, and there are large enough control surfaces, so there's not a lot of drag when it does initiate a roll or a pitch control. The hinges, instead of tape, they're going to be laminate, just a minor thing. I think the 140B is fine, but I would imagine over a long period of use, that tape hinges may eventually begin to collapse. Laminate's going to be a lot stronger. The winglets are the same. The motor mount is the exact same. The steel launch hook, just like the 140B has, is going to be built into the 140C, so I'm not going to have to modify the plane. That's why it's red. It wasn't originally designed in the 140B. This is something new, the parachute ring. Basically, I'm going to kind of do a little cheat here. I mean, this is kind of leading into what I'm working on now. I'm working on building a parachute for the 140. Here's the deal. When I come in for a landing, sometimes I'm going to have to come in really fast, and I'm nervous about how much glide ratio the 140B has. And so into the 140C, I'm going to build a launch or a parachute ring. It's basically going to be a little ring that's going to attach to the one of the carbon fiber wing spars, and it's going to be a hook above the airplane. And so what I'm going to do is I'm going to be able to allow a servo to open up a hatch and open up a parachute about the same size as the 140 is, and that should basically allow for a parachute landing, like totally like a parachuter would do. Anyway, it's going to be really interesting, and of course we'll be trying that. But the ring is just basically something that's hooked directly into the wing spar itself. Velcro battery retainers, nothing different there. And then it's going to be 100% precipitation sealed, so it could fly in rain. This is going to be the first airplane that can be it's going to be raining, foggy, whatever, and it's going to be able to fly through that. The 140B is pretty much precipitation sealed, about maybe 50-80%, so it can land in snow and stuff, but to fly in the rain, the 140B is not ready for that. But the 140C will be able to do that. So that's kind of the setup. Nothing's too different from the 140B. Again, these are the wings. These are the spars for the launch hook and parachute ring. And aside from that, there's the top is going to have is also going to have a carbon fiber rod and another one up here, just because there's a lot of weight up here, as you'll see in a second. Cool. So that's the airframe. Now here's the core flight components. This is going to look a little different, and I'll walk you through it in a second. The speed controller is going to be still 60 amps. The receiver is going to be Easy UHF 8-channel 433 megahertz. So we're going to a higher power, long frequency, longer range frequency. So instead of 2.4 gigahertz a turn G, we're going to go to 433 megahertz, and that's going to give us a lot more range, you know, well beyond line of sight. Of course, we're going to maintain line of sight during the trip, but it's just going to give us a lot more to work with. Also, because the that module will be external, so it's going to sit outside the transmitter on top of the vehicle, and so that'll allow us to control the airplane from inside the car with the controller inside the car, yet the antenna will be outside the car, so the car won't be, you know, basically a Faraday cage anymore, and allow us a lot better transmission of our radio frequencies. Our servos are going to be digital 32 gram, 3.8 kilogram servos instead of the 11 gram, 2.2 kg servos. So a little bigger, a little heavier duty. You know, this airplane's going to be heavier. It's going to have a longer endurance, longer flight. It's going to endure more abuse, and so they need to be a little stronger. And the servos I have now have been working fine. I just would feel a little more comfortable, sleep better at night if I knew they were bigger and a little more durable. The motor is the exact same size, 3542, except it's going to be a lower kV rating. And I'll tell you why in a second, but it's going from 1450 to 1250. Okay, now here's the biggest thing. The batteries are going to be 24 cells of 3.6 volt lithium ion 3.3 amp hour in 4S 6P configuration. In other words, 4 in series and then 6 of those in parallel. And what this is basically going to give us is it's kind of a long discussion, but these lithium-ion batteries, and that's why these little batteries you can see here, these batteries, now they cost twice as much as a LiPo battery, but they weigh half for how much power they give. So basically, if you were to match the same power, these lithium-ion batteries, in lithium polymer batteries, it would weigh twice as much. Now, I don't have the figures in front of me. I should have this, but if you multiplied 6 times 3.3, that would give you the number of amp hours this is going to carry. But the other deal is it's in 4S setup. So instead of 11.1 volts, I want to say it's 14.4 volts. So that's why the higher voltage correlates to a lower kV motor. Anyway, these batteries are incredible. This is going to give us per watt hour, and I should know this. In fact, I'll put this splash up on the screen here in a second. But the watt hours, which is probably a better measurement to carry, that's volts times amps. I want to say it was 111 with the 140B. And I'll correct myself here in a second if I'm wrong. But the 140C, I want to say is going to carry 230. So over twice the capacity, so it could fly twice as far. And to put that in perspective, the Raptor 140B just did a 52 kilometer flight using 80% of its batteries. So we're thinking 100 kilometers here on this setup, which would be just incredible. 100 kilometers would be very impressive. Okay, so the prop is going to be a 10 by 6 carbon fiber folding instead of a 10 by 7. Again, just one more pitched down. That's just because of the higher the higher voltage motor. Prop hub is the same. The wire management, this is not that exciting, but it used to be that my wires, and you probably see it in the 140B, they're just kind of just all over the place. And it just gets kind of hard to manage to add new components. So instead, this time I'm actually going to cut in little lanes, you can see here in gray, and this is going to allow my different wiring to be put in here. And that brings could be an interesting issue, because with those wires being such close proximity, particularly my telemetry and my FPV, yes, we're adding FPV to this, then we could have interference with the servos or other stuff. And so I'm going to be adding some ferrite rings or filters on my speed controller, my FPV, and my telemetry, as well as my camera power. And so a lot of red text here. That's a lot of changes for the core components. So that's that setup. So a little further down, the avionics have some changes as well. The camera, instead of the 808 camera that I have now, that's 720p, I have a Mobius I'm going to put on this one, and it's going to be 1080p by 720. And this also has AV output, so I'll be able to connect it to my FPV transmitter, and so I can record and transmit at the same time, and that'll be really helpful to reducing weight and just for simplicity. My FPV TX, I'm looking at Ready-Made RC. They have a 400 milliwatt 1.3 gigahertz. So that's the frequency I'm going for FPV, 1.3 gigahertz. And that should give me pretty good transmission. Now that's the not the strongest transmitter, obviously, but I think 400 milliwatts, not megawatts, 400 milliwatts will be plenty for what I'm doing. And really, FPV is important, but it's not the primary system that I'm going to be using. I'm actually be using telemetry probably more than FPV, although FPV will be important. The other thing to remember here, this airplane will be within a kilometer or so of the chase vehicle pretty much at all times. So 400 milliwatts is plenty of power, obviously. We'll have way more range than that, but, you know, I'll have a lot of excess just in case something comes up. The flight controller is going to be an APM 2.6. Not going to the Pixhawk quite yet. I'm just waiting a little more time to see how that works out. They're just shipping them now. I'm sure it's a great product, but I just want to give a little more time for the environment to kind of adopt that and to see how that goes. The current sensor is going to be on there, 3DR current sensor. I'm going to have a UBEC, I want to say 3 amps or 5 amps or something, but basically it's going to power the different components that need power, particularly, I believe, the telemetry, which I'll tell you about in a second, was going to demand more power, as well as that camera is pretty thirsty. So we're going to need power separate from our ESC BEC, because the ESC BEC is powering the servos. And then, of course, the APM is powered through the current sensor. So we have 3 power supplies on this airplane. It's going to be pretty cool. Okay, the compass is going to be the 3DR U-blocks with compass as well, and that's just like it is now. Telemetry, looking at going with the RDF 900, and that is a 1 watt 900 megahertz transmitter, or a transceiver technically. We used to have 100 milliwatts. Now 100 milliwatts would give us about 1.5 kilometers of range, so 1 watt is going to give us significant amount, 5K or more. I mean, obviously a lot. Way more than we'll need, but again, why are we doing that? Well, we're doing it just to overcompensate for whatever could occur during the USA trip. You know, for whatever reason, we become separated from the airplane. It'd be really nice to be able to maintain as much radio connectivity as possible. Lighting, going to add this kind of FAA style that's red, green, and strobe. That just makes it more visible to the pilot in low light settings, so like dawn or dusk, and just more visibility in general. And, oh, there's a power supply again. So I've got it in there twice, obviously. I'll delete that. I don't have one on there now. So that's the avionics, and boy, that went fast. There's obviously a lot to this. This is kind of everything together. Just kind of a quick view just to see how it all laid out. And, man, it's kind of anticlimactic, but it's going to be incredible. The airplane is going to have roughly the same thrust as it has now, although it will have more potential because it'll have the same speed controller, but it'll have higher voltage. So technically, on a really, an emergency situation could accelerate faster. But really, this airplane's its biggest improvement really is just stronger stuff. Bigger servos. A little stronger build construction, and then really it's about technology. It's about that FPV is brand new, a more powerful telemetry or transceiver is going to be huge, and the batteries obviously is the biggest. We're adding just a little bit of weight, but over twice, I believe, if I remember correctly, about twice the capacity. So just generally, we're getting closer and closer. Now, is this the airplane that'll cross the USA? Probably not. There'll probably be at least one more addition between this one and the next one, but man, this is getting close. I mean, this is starting to fit the bill of the USA trip more and more every time, and I'm trying to think of what else I'd really add. We may have to add more power. Obviously, this many watts, or this many watt hours, I think my calculations showed I'd need more like 300 instead of 200. So we may need another bank of these, but we are getting really close. Alright guys, now that's my setup. Let me know what you think. Am I missing anything, or any of my components not what you'd suggest? What do you think? I'm going to start ordering and putting this together right away, so be quick. And it's going to take about a month to put together, but soon enough, the Raptor 140C is going to be in the sky, breaking records all over the place. Alright guys, thanks for watching my Geek Show, and we'll see you next week. The Raptor 140 is an incredible platform. It's made from the strongest and most durable stuff on Earth and has awesome flight characteristics. It's also the result of 4 years of research to find the best design and materials for RC aircraft. If you want to build your own Raptor 140 and support the show, go to mygeekshow.com, click store, and you can pick up a handmade kit.